Hello and welcome to my channel Econ Academy. In this tutorial I will explain what is multicollinearity and how to detect it using VIF and how to treat it. So do like the video and subscribe to my channel. So first of all, what is multicollinearity? If one independent variable is a linear combination of another, we say that there is multicollinearity between them. But now question arises, what level of multicollinearity exists in our model? If there exists a low level, then we will say that it is not a problem, and if there exists a high level of multicollinearity, then we will say that there is a problem of multicollinearity in the data. One more thing, multicollinearity is a problem of data, not of model or estimation. So we can even check the multicollinearity before the estimation of our model. So the coefficient of OLS will still be blue even in the presence of high multicollinearity. The coefficient will be correct even in the presence of high multicollinearity, and R square might be false in case of multicollinearity because it will be very high, and in actual the R square will not be that high, but because of the problem of multicollinearity, the R square will be very high, and the standard error will also be very high of the variable in which there is multicollinearity. So this is something about multicollinearity. Now I will show you how to detect multicollinearity using variance inflation factor, or simply VIF. So for that, first of all, we will run the regression. So I have already imported time series data in Stata, and it can be any data, time series, cross section, or panel data. It can exist in any of the data. So I have already imported data in my Stata. Now I will run regression with the command reg and the name of the dependent variable, which is growth, and then the name of the independent variables, which is GS is gone spending, I is investment, GSV is gone spending volatility, and IV is investment volatility, and O is openness, and we'll press enter. So this is the regression. Now to estimate variance inflation factor, we will write VIF in the command section, and after the regression we will write VIF in command section, and we will press enter. So if this mean VIF is greater than 10 or equal to 10, then we will say that there is multicollinearity in our model, in our data, and we should treat it according to methods of principal component analysis, or we should remove one of the variable which have high multicollinearity, but that might cause our model omitted variable bias. But so principal component analysis is the best way. And according to Gujarati 2008, if VIF of any variable, like if the VIF of investment, in this case it is 3.59, if this VIF of investment is greater than 5, then we should drop that variable according to Gujarati 2008. But collectively you can check the mean VIF. If this mean VIF is equal to 10 or greater than 10, then we will say that there is problem of multicollinearity in our data. So let's suppose as in this case there is no problem of multicollinearity. Let's suppose we have a problem of multicollinearity, and the variables GS, that is government spending volatility, GSV, and I is is having multicollinearity. So we will make a principal component of these three variables and run the regression, run it in our regression. So for making principal component analysis, we write PCA, and we have supposed that the variable that is GSV, and I have multicollinearity, so we will write these three variable and we will press enter. Now we will write rotate and we'll press enter again, and now we'll predict a new series having the principal components of these three variables. So we'll write predict in the command section, and we write any name. Let's suppose we write ser as a series, and we'll press enter. So the new variable have been created with the name ser, containing the principal components of government spending volatility, and investment. In that case, this principal component was not required, as there was no multicollinearity in our model according to VIF, but we have supposed that there is multicollinearity, and we have predicted a new series of having principal component of government spending volatility, and investment, just to make you understand how all these how we treat the variable having multicollinearity. Now we will run a regression. We will write reg in the command section, and the dependent variable, which was growth, and then the new principal component variable, which is ser, instead of government spending volatility, and investment, and then the investment volatility and openness. So now we will run this model if there is multicollinearity and we have make a principal component of some variable. So we will replace that principal components with the variables which having multicollinearity. Now we'll press enter. So this will be our final model, and we will interpret this model. So this is from today's tutorial. Do like the video and subscribe to my channel. Bye for now.